7 Black hole facts that are not true. Are you really doomed to get sucked into a black hole, and are they really as big as you think? Mysterious, dangerous, and exciting black holes are a common feature in science fiction. But the way they are portrayed is not always accurate. These are the 7 biggest myths about black holes busted. Number 1. Black holes are eat things. Though they get a reputation for being like the very hungry caterpillar, black holes don't search out stars and planets to eat, and they won't go hungry if they run out of food in the neighborhood. Rather than a monstrous eating machine, it makes more sense to think of a black hole as just an area of space-time where the gravity is incredibly strong. If a star is near to a black hole, it will be pulled in by the gravity and may eventually be dragged past the point of no return and sucked into the black hole. But the black hole is not sustained by the matter it absorbs, and nothing will happen to it if it runs out of things to swallow. And number 2, black holes are huge. Some black holes are enormous. Supermassive black holes have diameters in the region of tens of millions of kilometers. But that's not guaranteed. Some black holes are much smaller. Stellar mass black holes, those with a mass similar to our Sun, can be absolutely tiny. In fact, in 2019, astronomers found a black hole thought to be only 19 kilometers across. Number 3. Anything near a black hole is doomed to get sucked in. A black hole's gravity is incredibly strong, but other than that, it's not different to any other type of gravity. The gravitational force due to a black hole 10 times the mass of the Sun is exactly the same as that of a 10 solar mass star. So, an object close to a black hole will act exactly the same as if you swapped the black hole for a star of the same mass. In fact, it's perfectly possible to orbit a black hole. Not only that, but some scientists believe life could exist on planets orbiting black holes. Number 4. You can't see a black hole. It's true that once light passes the event horizon, also known as the point of no return. This is because the gravity is so strong that the escape velocity, the speed something would need to travel to escape, is greater than the speed of light. But there are several ways to spot a black hole. One is by looking at the way stars around it move. In 2002, astronomers managed to capture the motion of a star named S2 around the object at the center of the Milky Way. The star was clearly orbiting some invisible thing, and that thing is what we now call the supermassive black hole. Astronomers got an even closer look at a black hole in 2019 when the Event Horizon Telescope captured an image of M87. M87 is a supermassive black hole, and it is surrounded by a large accretion disk of stars, gas, and other material. Spiraling in towards the center, the material is heated by the friction as it swirls around at near light speeds and gives off electromagnetic radiation. Using telescopes all around the Earth to make one planet-sized telescope, EHT captured a now famous image of this accretion disk. On number 5, black holes are holes in space-time. A black hole is a hole in the sense that if something falls into it, it will get trapped in there. But it's not literally a hole in space-time. It is, however, a region where the laws of physics start to get messy. What happens on the inside of a black hole? Well, we have absolutely no way of knowing for sure. Not even light can escape from one, so we can't see inside. However, some physicists believe that black holes could actually be portals to other places in the universe known as wormholes. Number 6. Black holes stay in one place. It's easy to imagine that a black hole is the fixed point in space-time, dragging all nearby matter inwards to meet its eventual fate. But that's not the case. Like stars, planets, and everything else in the universe, black holes are mobile. In fact, the first gravitational waves detected in 2015 were the result of two black holes colliding and merging. The two orbited each other, spiraling ever closer and closer before they finally merged with a crash. Number 7 and last, a black hole would kill you by crushing you. Black holes are the densest objects in the universe, and you absolutely could not survive the crushing pressure. But that would not be what you kills. What would kill you is an effect referred to honestly as spaghettification. Imagine your falling feet first towards a black hole. Gravitational forces are always stronger the closer you get to the object. But with a black hole, the difference is so noticeable that the force on your feet is much stronger than the force on your head. That means your feet would be accelerated towards the center of the black hole much more quickly than your head, and you would be stretched out like spaghetti. Your entire body would be pulled apart.